report basically is cut across a few sections. So we cover research, industry, politics, and safety, mostly focused on what's happened over the last 12 months. And the overarching goal is to really try to inform conversation across these different areas as AI becomes even more important in the world. And we focus on its implications for the future. It's all free of charge. There's no sponsorship, and you can download it and feel free to kind of email feedback. And I hope to integrate some of your thoughts in the future and your work in the future. We have a bunch of reviewers. I think this year about 30 or so people who are in the space to try and keep us honest on representing the work and not missing out on anything that's important. So thank you to those of you who spent time checking these slides over the last 2 weeks. So to kick things off on what I thought was the most kind of topical in research. I mean, first of all, kind of no surprise here today, but I'd say it was a pretty big surprise a couple of months ago. We saw massive capabilities improvements in general purpose models like GPT from OpenAI. I think the thing for me that was the most interesting here was really that this model exhibited capabilities at a certain scale that were not present at smaller scales. And I think this topic of potentially what is emergence, we'd love to dig into a bit later on. Now, this model obviously smashes classical NLP benchmarks that are somewhat obsolete, but it goes beyond that and goes into kind of human knowledge work tasks like bar exam and the GRE. It still suffers from issues like hallucinations, which we'll get into as well today, but it really showed how reinforcement learning from human feedback, a sort of form of supervision, was becoming more and more central to the model's capabilities. On the other hand, in open source, we saw a huge kind of acceleration of enthusiasm and models getting produced, originally with the first Llama about 7 months ago and the second Llama just probably a month ago or so, and many other companies contributing, whether that's Mosaic, Adept, Eleuther, Mistral, and others. And what's interesting here is a lot of work on creating parameter-efficient models and new fine-tuning methods that try and make these models more accessible to companies of any size for any application. We did some data mining the popularity of various models, and here we plot you the performance of a model according to this metric on the y-axis, and the date of release, and the size of the bubble is basically its popularity. And you can kind of see that in purple or pink are the proprietary models, ChatGPT, GPT-4, kind of winning a lot of attention. And then on the research-only open source side of things, it's really the Llama show. And apart from those, there's a variety of others, but these are really the two kind of hottest games in town. We shifted from 2 years ago talking about parameter size. We had a chart kind of jokingly a few years ago about entering the billion parameter club, to now focusing on features like context length. And I think this is kind of an indication about how we're trying to move to models that are actually useful for everyday work. There are issues that have emerged around compute and memory bottleneck issues. There have been a variety of approaches to try and increase context length without reducing retrieval quality and generation quality. And some questions that have emerged around, is context and context length all you need? There's a kind of an opposing force here also trying to build models that are small and focus on actual training data and fine-tuning techniques that are used. And some interesting but early evidence that you could in fact train much smaller models with curated data sets that might even be generated with larger models to outperform their large peers. And so really a renewed focus on high quality input tokens. And zooming out to other areas, in particular one that we'll dig into today in biology, some real improvements on predicting structure by essentially learning across the entire evolutionary scale of protein sequences and showing that these kinds of transformer-based systems can recover kind of evolutionary artifacts that are important for dictating how proteins are structured and will fold without some of the priors that had to be used before, like multiple sequence alignment. Going into clinical medicine, we saw huge improvement on this expert task of answering questions on the U.S. medical licensing exam. And what I find particularly interesting here is that in an actual panel assessment of physicians, turns out that physicians actually prefer responses that are generated from this model. So I find it quite interesting to see where this space will go, and it also highlights the importance of of domain-specific fine-tuning and prompting strategies, which again is kind of another layer to me that indicates that one model might kind of learn them all and own them all task-wise. Then what is perhaps striking and concerning is that there's a lot of concentration as to where all this research is happening. And given that there's a lot of discussion of AI at the nation-state level, it's quite significant to me that 70% of the most highly cited AI papers are from institutions based in the US, and a lot of them from big tech companies. China ranking in number 2 and the UK roughly in number 3, and this ranking basically has remained roughly unchanged for a very, very long time. So switching into industry, we started talking about compute a few years ago, and we have quite a big section on this. We illustrate this chart of how NVIDIA has really blown out its earnings and entered into this $1 trillion market cap club. I think in many ways this is probably unsurprising to every one of you in the room, but it was certainly surprising to almost everybody on Wall Street. We started documenting and doing kind of data mining on all open source AI research papers, and specifically looking at enumerating the number of papers that make use of NVIDIA chips, FPGAs, big 5 startups, TPUs, and other chips. And here we plot, this is a log scale. It's important to point out that all papers that use NVIDIA chips, there's about 150 times more of them than the sum of all big 5 startups, TPUs, ASICs, et cetera. So the chasm is only getting bigger, actually. We also look at the specific chip that's used in an AI research paper, and here we show you all the popular NVIDIA ones. And to me, what's remarkable looking at this graph is that actually the most popular chip from last year was this V100 card that was released in 2017. And so this is a card that's almost like 5-6 years old and is still becoming the workforce for AI research. And if you sort of unscientifically continue this bell curve chart and consider like where it might drop to 0, and then sum the number of years, you're looking at basically a decade. And so it's quite astounding that a company that's shipping a new chip every year and probably an update every half year is producing products that will be alive and used in everyday research for a decade. We, a year ago or so, started like a kind of compute index section for the report, enumerating the size of A100 clusters. And now we've extended this to H100, so we're just actively tracking some of this data. Of course, it's incomplete because a lot of this information is private, and we don't breach that even if we know. But a lot of these clusters are getting built. We're aware of that, and certainly not without their hiccups. This is all important because, as you know, like scale drives performance, and it's also astounding to me that I think it was just a year ago, 2 years ago, that OpenAI did their big fundraise and were marketing to investors that they would go from 0 to 20 to $1 billion to $5 billion or whatever the numbers were. And I think a lot of us in the investment community kind of looked at that and probably scoffed and thought it was not possible. But it turns out that it probably is, passing $1 billion in revenue. But at the same time, at what cost? And at what cost does that start to matter given this kind of high inflation and rates environment that we live in? There are, of course, many industries that are starting to feel the kind of ChatGPT heat. We give you an example of education. We have others in code. This one I thought was still quite meaningful, that a public company in education saw its share price drop by 50% on the day of launch of ChatGPT because customers could basically get the equivalent capability from another service and perhaps an even better one. But at the same time, companies, big tech companies and public companies are reacting. So in this case, Chegg, is teaming up with Scale AI, and in their investor reporting, they start talking about building LLMs themselves. But while there's a lot of kind of wow effect in generative AI, we also thought it was quite striking that some analysis looking at the monthly retention and daily active users and monthly active users of kind of popular internet products versus AI first products were quite markedly different. So in 1 month retention for a traditional kind of web product like YouTube or Instagram or TikTok, median retention is 63%. But for admittedly a small cohort of AI first products, it's 42. So I think it's still incredibly early in this market. I think a lot of this activity kind of popped off last summer, but everybody has their eyes on these kinds of metrics. So for entrepreneurs that are building companies, it's really important to not just think about growth, but actually how actively your users are engaging with your product. Quite excitingly, open source AI has really been on a tear. Sort of proverbial like town hall for AI on the internet, Hugging Face, has seen massive acceleration to the amount of models that are posted on their hub. I thought it was quite astounding that just last month 600 million models were downloaded, and we'll get into some of the Llama downloads as well, which are pretty astounding. Areas that were once ignored by major kind of incumbents, and here I take the example of pharmaceuticals, are now like legitimately making a move in AI, and we'll get into a bit of that as well in the discussion. But there was some big acquisitions for machine learning companies. There's one of the oldest pharmaceutical companies in the world that says they're quote going all in on this, and so it's exciting to see incumbent sectors that were a bit kind of slow or unwilling to adapt, start to find real value. A year or so ago, maybe 2 years ago, we made this little slide about all the authors on the original Attention is All You Need paper. And I think it seemed to be on Twitter, like the first time that people actually realized that most of the people on this paper no longer work there. And so we made a little update this time, because now I think finally everybody who wrote a paper now has a startup. And which is really exciting to see, and it covers enterprise software, general purpose models, and even biology. Of course, we read about generative AI fundraisings all the time. The main thing that stuck out for me was if you rip out all Gen AI funding in the last year, you would get a 40% drop in overall AI investment. So it's really that this space is under the proverbial magnifying glass with the sun shining on it, and it's like everybody is doing the exact same thing right now. And so I think like if competition feels rough to you right now, I think at some point it will abate, as there will be other options for people to work on. But like certainly in the funding charts, that story rings really true. It's also quite astounding, and I think we'll look at this historically as I don't know, maybe like an artifact or something that was crazy or great. But it's just astounding that 16 billion or so was invested just last year, and most of this money is going for compute. And in some ways, it's kind of reminiscent of during the social era with Facebook and Google, where startups were raising money to go buy Google ads and Facebook ads to grow on those platforms. So we have a prediction around what might happen here as well in the end of the report. So yeah, now going into politics, I think. Well, what's interesting is like AI is really front and center for policymakers now, and that's changed significantly in the last like 2 years. We kind of describe it as being in a mode of peak regulatory divergence, which is to say, some countries are thinking about relying on existing regulators and upskilling them to consider their specific verticals, like in the UK, the FCA or the MHRA in medicine. There are some countries and continents that are introducing AI-specific frameworks, treating AI as a fundamentally different technology that needs a new regulator, and the EU AI Act is one example of this. On the other end of the spectrum, there are some countries that are just flat out banning certain services. And we hear a lot about, is AI like atomic energy? Should we have an atomic energy agency to sort of patrol and like bring compliance to AI? I think it's a fundamentally like different thing, because unlike atomic energy, where a lot of the research was being done in government funded labs by government money, a lot of AI is being built by you and by private companies. And so how are you supposed to monitor that? And AI is not like uranium enrichment. You can't track it as easily. So in that void, large labs are really stepping in and engaging with government, while government tries to make up its mind. So we've seen all the big labs who understand their models because they built them. They increasingly understand the risks through pretty sophisticated red teaming experiments. And they're launching proposals to policymakers. There are organizations like the Frontier Model Forum, which is a club of like big tech companies trying to figure out what policy positioning they should propose to government, such as licensing regimes and audit requirements. But at the same time, the open source community and startups, many of which are represented by people in the room, are rightly voicing that licensing and audit requirements are typically things that big companies can stomach. And so regulation might, as it often does, favor large players. So I think if there's one message I would have here is like, even if you don't care about politics or regulation, I think it's quite important that you express your opinion because many of the big players are. And this will ultimately have an impact on the kind of work that you can do. And yeah, it's important that the whole spectrum of the ecosystem is really considered. Geopolitical tensions have, are increasingly on the rise. We have yet another war now, a horrific tragedy happening, and politics between China and the U.S. is not getting better. The U.S. has barred the sale of advanced chips to China and has managed to actually get, Japan and Germany and the Netherlands and others to kind of bandy. And we illustrate this on the right with imports to China really dropping significantly, which will be interesting to consider how that affects progress. So on safety, I wanted to just point out that 2 years ago, we didn't have a safety section. And we created this graph in 2021 by basically looking at all the major safety publications and alignment publications that came out from major labs and counting the number of authors on those papers and asking the labs, how many people on your payroll, on your teams are actively specifically focused on AI alignment. And, we came up with roughly 100. It's probably being generous at the time. And we honestly got quite a lot of flack for doing this. Forward 2 years, and this is the kind of headlines that we're reading today. Things like, I don't know, like we're going to die, or, rogue AIs are going to take over, we're producing godlike intelligence, et cetera, risks of extinction. And in the moment, I don't know, it's easy to kind of get absorbed into this, but I think it's just really fascinating how 2 years ago, nobody cared. And 3 years ago, what we cared about was models having bias and, making the wrong decisions for fraud or credit scoring or facial recognition and things like that. So it's really escalated. AI safety and these topics have really obviously won the hearts and minds of lawmakers and government. We've seen the US NSA start an AI security center. A lot of the biggest companies have been testifying in Congress. Quotes like there's an alarming combination of imminence and severity, giving examples of bioweapons and AGI. Like this is some pretty serious stuff. And it's just quite striking how quickly it's happened. In the UK, last year's co-author, my friend Ian Hogarth, has been leading a Frontier Model Task Force, which is putting together kind of the first global AI safety summit on the 1st and 2nd of November, with the goal of trying to address some of these questions and kind of come to some form of agreed posture and suggestions. So it'll be really interesting to kind of follow where we go. But again, I think it's important, if you did get an invitation to this, to consider going, because this is kind of one of the main forums that we'll see where the kind of regulation in the space goes. We do a couple of predictions every year just to kind of keep things fun. Here I just show you the scorecard from last year. You can kind of dive into it at your leisure. We made 10 predictions this year, and I won't go into all of them specifically, but they cut across like big tech companies, regulation, the FTC, AI governance, GPU debt funds, self-improving AI agents, generative AI for media, electoral manipulation, and all sorts of other stuff. So yeah, we'll keep our eyes peeled over the next 12 months to see how many of these kind of avail or don't avail. That's just like 20 slides out of 150 or so. There's a lot of other stuff that you might find interesting. And so I encourage you to have a look, and please drop us a line. Any corrections are also welcome. It's a living document for sure. And for those of you whose work we featured, thanks for doing it. It certainly makes it fun.